Welcome to this lesson video. Today we'll be looking at how to calculate molar mass. Now normally to calculate molar mass is very important because we all know that in chemistry we have what we call stoichiometric calculations. So in most cases, in order to find the number of moles of a particular substance, we need to know how to calculate the molar mass. When we want to calculate the concentration, we need the molar mass. When we have to calculate the limiting reagent and excess, we need the skills of calculating molar mass. So in most cases, learners, they are having this challenge of calculating molar mass. Sometimes you may even forget. So I decided to create a quick lesson video whereby I show you how to calculate the molar mass. It's pretty simple. We are going to use the periodic table. Now we all know that the question papers from the Department of Education, they have the periodic table. So the periodic table, it's always provided. Now how do we analyze the periodic table and use it to calculate our molar mass? Now if you can notice here, each and every element we have numbers. Okay, this is the periodic table. We have a number of elements. And then let us look at this. Now you can see that for each symbol of elements we have on the periodic table, we have what we call the atomic number. The atomic number is just the number above each symbol of elements on the periodic table. And then on the left hand side we have what we call the electronegativity. So you can see the electronegativity is this number here. And then at the bottom we have what we call the relative atomic mass. So don't get confused when I say atomic number, electronegativity, or relative atomic mass. Now today's lesson we are going to look at relative atomic mass. Now let's say we want to calculate the molar mass of H2O. Now we check. In this compound we have two different types of elements, and then we focus on each element. Now let us start with hydrogen. How many atoms of hydrogen do we have? We have 2. How many number of atoms do we have of oxygen? We have 1. So since there's no number here, we must know that it's 1. So this is how we generate our equation. The molar mass of H2O is equals to, how many number of atoms of hydrogen do we have? We have 2, so we are going to put 2 here. And then we open bracket, we close the bracket, plus how many number of atoms of oxygen do we have? We only have 1, we put bracket. Now inside the brackets, what do we put? Now we look at the periodic table. Locate hydrogen. Hydrogen is element number 1. Now look at the relative atomic mass of hydrogen. It's what? It's 1. So inside the bracket we are going to put the atomic mass of a single hydrogen atom. So we are going to put what? We are going to put 1. Let me use a different color. We are going to put 1. And then we locate oxygen. It's element number 8. So what is the relative atomic mass? You can see that it's 16. So we are going to put 16 here. Now you simply sum it up. 2 multiplied by 1, it's 2. 1 multiplied by 16, it's 16. Then 16 plus 2, simply 18. So the molar mass of H2O, it's 18. And the SI unit is what? It's grams per mole. That is the SI unit of molar mass. Now let us quickly go to our next exercise. Now the best way to learn is to engage yourself in this lesson videos. So for the next exercise, I urge you to pause the video, work out the question, and then try to find your answer, play the video and verify your answer. So let us calculate the molar mass of CO2. Now pause the video, then play the video after working out the answer. Now the molar mass of CO2, it's equals to how many number of atoms of carbon do we have? We only have one. We open the bracket, plus how many atoms of oxygen? We have 2. Open the brackets. So we are trying to say is the sum of the elements which makes up this compound. So let us locate carbon. We have 12, and then oxygen we have 16. Then 1 multiplied by 12 is 12. 2 multiplied by 16 is 32. And then 32 plus 12 is 44 grams per mole. I hope you got the answer. Let us go to our next exercise. Now let us work out this one. H2SO4, sulfuric acid. Now the molar mass of sulfuric acid, we have 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. So hydrogen, the relative atomic mass is 1. For sulfur we have 32. For oxygen we have 16. Let us simplify. 2 multiplied by 1 is 2. 1 multiplied by 32 is 32. 4 multiplied by 16 is 64. Now 2 plus 32 plus 64, the answer is 98 grams per mole. I hope you got this one correct. Let us look at another exercise. Methane. Now the molar mass of methane, you can see we have 1 atom of carbon plus 4 atoms of hydrogen. What is the relative atomic mass? It's 12. For hydrogen it's 1. So 1 multiplied by 12 is 12, plus 4 multiplied by 1 is 4. 12 plus 4 is 16 grams per mole. Now let us look at one more question. Ammonia. Now the molar mass of ammonia, we only have 1 atom of nitrogen, 3 atoms of hydrogen. Now the relative atomic mass of nitrogen is 14, hydrogen is 1. So 1 multiplied by 14 is 14, 3 multiplied by 1 is 3. our final answer is 17 grams per mole. Now that's it for this video. This is Bahula SJ. Just make sure that you also watch the next coming lesson videos, whereby we talk about the number of moles, the concentration, how to determine the number of moles of the other substances in the chemical reaction using the molar ratio. Now, thank you very much.